Types of reactions. There are 4 types of chemical reactions that we are going to see in this video. Synthesis or combination reaction, decomposition reaction, single displacement or single replacement reaction, double displacement or double replacement reaction. First, we will look at synthesis or combination reaction. By definition, when elements combine to form compounds, the reaction may be considered as a synthesis or combination reaction. This is for very basic understanding of the concept. So any 2 elements from the periodic table, 2 or 3 elements, if they combine to form a compound, then the reaction may be classified as a synthesis reaction. Here is an example: sulfur plus oxygen, giving you sulfur dioxide plus heat energy. A new product is formed, sulfur dioxide. The reactants are both elements, sulfur in the solid state and oxygen in the gas phase. React to give you sulfur dioxide. Hence, this reaction can be considered as a synthesis reaction. Reactants are elements and the product is a compound. In the process, energy or heat is also released. Carbon plus oxygen giving you carbon dioxide plus heat energy. This is again a synthesis reaction because a new compound, carbon dioxide, is formed from elements carbon and oxygen. The second type of reaction is decomposition reaction. A decomposition reaction, as the word indicates, is the opposite of the synthesis reaction. Synthesis reaction, we put together elements to form a new substance. Decomposition is the opposite. It is breaking down of the compound into simpler elements. When a single compound breaks up to give you more than one element or compound, the reaction is called a decomposition reaction. Usually, there is a single reactant and more than one product. That's how you can identify a decomposition reaction. Calcium carbonate is a compound. If you heat it, it breaks up into 2 things. One is calcium oxide, which is a solid, and carbon dioxide, which is a gas. Hence, this reaction is classified as a decomposition reaction. The second example is a different carbonate. It's magnesium carbonate. Again, heating it will give you magnesium oxide, a solid, and carbon dioxide, a gas. The third type of reaction we are going to look at is called single displacement reaction, or we call it single replacement reaction. Either is fine. An element reacts with a compound to produce a new element and a different compound. In this case, the element is usually the more reactive element, which displaces the less reactive element from the compound. In order to identify such reactions, we will also need what we call the activity series or reactivity of metals. So here is a generic equation. A is an element, BC is a compound. If A is more reactive than B, then a chemical reaction will take place and it will produce a new element. What I mean is an element by itself from the compound BC and a new compound AC. So A is more reactive, B is less reactive, and that's why this reaction takes place. So here we have copper reacting with silver nitrate. Copper is an element, silver nitrate is a compound. If this reaction takes place, it is because copper is more reactive than silver. So in this case, we consider copper to be more reactive, silver to be less reactive. Therefore, copper can displace silver from silver nitrate. So it's merely exchanging the metal from the compound with a more reactive metal. Now, this is what we refer to as the reactivity series. So you need this list. If you do not have this list, answering these questions may be difficult. This list is obtained from standard reduction potential values of elements. We are merely going to use this reactivity series to make our predictions. So here, if you look at the list, I have just underlined copper and silver. Copper is higher than silver in the list, therefore it's more reactive. Or we can say lithium is more reactive than gold. So that's what we're going to look at, which is more reactive, which is higher in the series. That element will be more reactive. So copper is more reactive than silver. So here's the reaction that we had seen earlier. Copper reacting with silver nitrate to give you silver and copper to nitrate. The more reactive element that is on top as an element by itself. Silver, the less reactive element in the compound, silver nitrate. If they are allowed to react, it will produce silver element and copper nitrate. Here are some examples that we are going to work out. We are going to predict to see if these reactions will take place or not. And the answers to the questions will be provided here. And all of these are based on the activity series provided on the right. So zinc solid is a metal. It can react with copper to sulfate, which is dissolved in water. And will a reaction take place or not? Will it produce zinc sulfate and copper? That is what you have to say. Okay, so if you look at zinc, we have zinc over here and we have copper over here. Okay, so zinc is more reactive than copper. Since zinc is the metal and copper is the element in the compound, which is less reactive, this reaction should take place and this should be the product. So zinc reacts with copper sulfate, producing zinc sulfate and copper, because zinc is more reactive than copper. Let's look at the next reaction. Copper to nitrate reacting with silver metal to give you silver nitrate and copper. So the question is, will this reaction take place? So let's look at the metal element here. That is silver. Silver is over here and copper is over here. So the element is less reactive than the metal in the compound, so this reaction will not take place. It should not. So the answer is no. Copper to nitrate and silver will not undergo chemical change. Let's look at the next reaction. Magnesium metal and aluminum sulfate. So let's go identify magnesium is over here. We have magnesium over here. Aluminum is placed just below it. So we have magnesium on top, aluminum at the bottom. Magnesium is more reactive and aluminum is less reactive. Therefore, the reaction should take place, and that's what we should be seeing in this chemical reaction. So that is true. Magnesium will react with aluminum sulfate to form magnesium sulfate and aluminum. So the whole idea is you should be able to make a prediction when you see a reaction in which an element is reacting with a compound, which represents a single displacement reaction. We have one more reaction, I believe. Let's look at that. Aluminum sulfate and zinc. So let's just look at that. Aluminum we have here. Aluminum is in the compound and zinc is over here. So aluminum is more reactive than zinc. So aluminum is present in the compound, therefore, and it's more reactive, therefore it will not undergo any more chemical change. Zinc is an element, is less reactive, remains as an element. Therefore, if you try to add zinc to aluminum sulfate dissolved in water, there will be no chemical reaction. And that is true. So that's how you use the reactivity series to make predictions as to whether a chemical reaction will take place or not. And this is one of the uses for the activity series. And finally, the fourth kind of reaction, which is called a double displacement reaction, or sometimes referred to as double replacement reaction. When two compounds in aqueous solutions are mixed, there is an exchange of metal ions with the non-metallic ions. That's when a double displacement reaction takes place. Aqueous solutions are solutions where the ionic compounds are soluble in water. They kind of disappear. Sometimes they may have a color, but still they disappear. You don't see any solids in the aqueous solutions. They exist as ions, which are hydrated. It can also be considered as an exchange of anions, which are negative ions, with the metal ions. Both statements are accurate. It means the same. So let's look at an example. The generic reaction here in this case is AX, which is soluble in water, therefore we write AQ, is reacting with BY, which is soluble in water, again AQ. Both solutions are aqueous. When you mix these solutions, if a chemical reaction takes place, usually a precipitate is formed. A precipitate is a solid that is formed, and it can have a very specific color depending upon the ions that have taken part in the reaction. So in this case, A was bound to X and B was bound to Y. Because a chemical reaction takes place, in the product side you find that A is actually bound to Y and B is bound to X. And AY is a solid, and that would be a precipitate. Let's take an example. Potassium chloride can react with silver nitrate to give you potassium nitrate and silver chloride. Actually, if you perform this reaction, you will see that you will get a white precipitate of silver chloride. And in order to predict that, we would need what we call solubility rules. But for simplicity, whenever a double displacement reaction takes place, one of the products will be a solid, the other would be an aqueous solution. And in these cases, the products always have the positive ions interacting with the negative ion of the second compound. So this is what would happen. Potassium would replace silver from silver nitrate, and silver would replace potassium from potassium chloride. That's what really happens. Such a reaction is usually referred to as a double displacement reaction. In order to predict whether this reaction will take place or not, we can look at the solubility rules. So this is a list of rules. You can find this anywhere, and you should be able to interpret these rules. That's all that you need. So we're going to look at the soluble compounds and insoluble compounds. So there are certain generalizations that we can take into account. So we're going to look at this block. So here it says, if the metal ions in the ionic compound belong to group 1, which means lithium, sodium, potassium, rubidium, and cesium, along with ammonium ions, if any of these positive ions are present in an ionic compound, it will always be soluble in water. That's something that you may want to keep in mind all the time. Group 1 metals from the periodic table and ammonium, all the time their compounds are soluble in water. The second aspect that you may want to look at is coming from here. Nitrates. Over here, we find that if the ionic compound has the negative ion or the anion is a nitrate, a bicarbonate, or a chlorate, again, all of these compounds will always be soluble in water. Finally, we have halides and sulfates. Most of the halides are soluble in water with the exception. So that's when we look at the insoluble exceptions. If the halide is silver chloride, mercury chloride, or lead chloride, then it will be insoluble or it will form a precipitate. So you need to know this information. Most of the halides are soluble, but silver, mercury, and lead, they are insoluble in water. Similarly, for sulfates, most of the sulfates that are soluble are belonging to group 1 and ammonium. And there are a few sulfates that are not soluble. Silver sulfate, calcium, strontium, barium sulfate, mercury, and lead. So all of these sulfates are insoluble in water. All of the sulfates will be soluble. Again, generalizing, carbonates, phosphates, and chromates, along with sulfides and hydroxides, they are usually insoluble. The exceptions being, they will be soluble when the cation or the positive ion associated with these negative ions come from group 1 or ammonium. Then they are soluble. If not, all carbonates, all chromates, all phosphates, and all sulfates are always insoluble. And for hydroxides, most of the hydroxides are insoluble, and the soluble hydroxides usually contain alkali metal ions and barium ions. So group 1 hydroxide, ammonium hydroxide, and barium hydroxide are usually soluble. So if you know these rules, you should be able to predict which compound will be a solid or a precipitate during a double displacement reaction. That's it for now for the 4 types of reaction that we had seen.